Hello and welcome to my presentation on flexibility and shorter changeover times in the packaging manufacturing processes of photonic integrated devices. My name is Niels. I'm a manager engineering in Etteplan and I'm responsible for the development of our machine platform and the software innovations that we do. I have over 10 years experience in the automation industry and I have a passion for the automation business and production processes. Today I'm going to give you a sneak preview of the innovations that we've made in solving some of the challenges that we see today in the photonics industry. First of all, Tegema is the company that previously was known for the machine platform that we've developed, and we've been acquired by Etteplan in 2020. Etteplan is a large company with the headquarters in Finland and is an engineering company that provides high-tech solutions to customers in the product equipment manufacturing industry and also in product OEMers. Etteplan has over 4,000 employees and has a revenue of 350 million euros in 2022. We have locations all across the world, specifically in the northern part of Europe, of course, in the middle part of Europe, and also locations in the USA and in China. We in the Netherlands, Etteplan Engineering Solutions, is a high-tech system integrator aiming to provide solutions in the production process industry where we provide solutions where high accuracy is key. So we provide solutions for customers to optimize their production performance and also help their companies in engineering product solutions and to provide the right tooling and equipment for that. In the pictures you see over here are some of the examples that we've built in the past for customers. These examples include alignment from CMOS sensors to lenses, and also of course in the photonics industry fiber to PIC alignment or fiber to fiber alignment. And subsequently we also specialize in the processes of joining and bonding. Today we see in the photonics industry challenges, especially in the packaging section of the manufacturing process. What we see is that flexibility, repeatability and yield is a big problem. Especially in what we mean with flexibility is that we see that due to the fact that a lot of companies, product OEMers, research institutes are developing new products for the photonics industry market, but have not been able to come up with a high volume product design yet, and are still in R&D phase, and they're looking to scale up. But that also means when you're still in the development phase, in an R&D phase, that a lot of designs need to be validated or checked and then iterated in order to come to a higher TRL level. The thing is that this actually takes quite a lot of time, and also having to change the equipment necessary for the testing of this production, of this product, requires a lot of time, and therefore changeover time is key, we think, in solving one of these issues. Another issue is repeatability. We see small series that are being manufactured either manually or with a, let's say, built-in a test setup with a lot of different components from different vendors that are not integrated together, which leads to a very inconsistent result in the performance and therefore in iterations necessary in order to come up with a repeatable production performance. Last but not least, also yield is an issue due to the fact that people are manually assembling components, that we have a lot of variations in in the way that the products are being assembled, and causing to human error where the product needs to be thrown away when an error occurs. This also induces a lot of extra time and additional costs. Now, one of the examples, I was at a customer a couple of weeks ago, and there they actually used for the validation of their new development, and for small series they've used built together a system, alignment system and dispensing system from different vendors which were not completely integrated into each other, and the engineer working at this setup had to completely program a user interface around it in order to be able to change the process sequence, change alignment steps in order to essentially assemble the product together. Changing that for each iteration or for a new product took somewhere in between 1 and 3 or more days. Etteplan is involved in a Horizon 2020 project called the Ultra Fast Track to Innovation. And in here we are working together with Black Semiconductors and AMO to develop a product, a photodetector, and commercialize it, where the product is equipped with graphene material necessary to continue with the new development in this industry for the data communication industry. Now, our challenge in this project was to develop and deliver the equipment, being able to assemble this photonic transceiver in a packaging step, so the back-end assembly of the production, where we needed to do alignment, the dispensing part and the queuing part. And we delivered our machine, but there was also a challenge in order to being able to withstand changes that kept occurring during the project, in such sense that it was very easy for the customer to change steps in this machine to cover the changes that were required. So the system needed to be flexible and also reliable for the changes that we had to make for the product. So our solution was to come up with a flexible software solution called flexible programming solution, together with our R&D setup, in order to help then these partners in this project to overcome the challenges with flexibility and changeover times. Now, I'd like to address that for the development of our machine platform. We have modules, and in those modules there are several systems that can be integrated to cover the part of either the alignment, whether it's coarse alignment using a camera, or fine alignment using light, or actually electrifying the PIC that is necessary, and several other systems can be integrated into this platform, whatever is required for either in the R&D process but also for high volume. But for the software itself, we were usually integrating our standardized, which is common in the industry, use a machine PLC in order to cope with the in and outputs of the system and the logic behind it. Having to cope with the requests from our partners to come up with flexibility in the system, we have developed this software innovation. Now, in order to come up with a process, we had a brainstorm session and think about solutions that could help our customers in that sense. And we've been inspired by products that are already in the world out there today, like Lego Mindstorms. Even our children can use that. That's specifically for children, actually. We've seen the open source software called Blockly, where it is very easy to basically move around the blocks that are necessary for your software programming, inputs, the parameters, without having to type or to program really the words or the text that is necessary. It's completely visually set up. And we liked that idea, and we thought that could benefit this project and also the challenges that we see in the industry today. So we innovated this software. Now, I'm going to show you a little movie that gives you a little clear overview on how it actually works as we've currently developed it. As you can see, we have several modules that can be integrated into your production sequence from up top to below. And now we're integrating this gantry module where we parameterize the different positions, and we start the production until it's completed. And whenever the system says it's ready, you can easily change or add additional modules or parameters to whatever is required for your production sequence, and you can start it again. Now that's finished. It also gives you, of course, the feedback that the system is finished, and you'll be able to save this production sequence, save the parameters to whatever it is required. Now in this slide you see one of a couple of the key features of this innovation, where, as I mentioned, you can parameterize and configure the motion and process modules as required. You can start, stop, abort or halt your production run or your production sequence to whatever is necessary, and it's really just a click of a button and the system starts for you, so you don't have to do strange or multiple steps in order to actually start up the system. Saving and restoring or editing recipes or the parameter sets, production sequences is also part of the functionality of the system, as well as including loops or iterations. So you can, for example, do multiple alignment steps in order to find your highest power throughput, and also conditional statements when alignments or dispensing actions does not execute in the way that you have expected it, that you can do a loop back, for example, or change the way that the motion system interacts. It's really easy to use. As you can see, it's very drag and drop, so it's very intuitive, and you can copy, delete, and modify with simple interactions. Now, to give you a little clearer example of how the system interacts with the system, and there's another short movie which I'm going to show you, where we have depicted a specific set or a screenshot of our machine, a virtual environment of our R&D machine in this sense, where you can see the gantry moving around together with the dispenser. And here we depict how easy it is to have both these modules within our system integrated into this production solution software, where you can easily adapt both systems in order to optimize your process. Now you can see we've already made a simple sequence step, and where we run the system, you can actually see the dispenser moving around and doing its thing basically. And now we change, as you can see, some of the parameters of the dispensing action, and now together with the dispenser, also the gantry moves and interacts in the way that you've parameterized it. It's all real time, so it's not sped up or anything, it's just real time as you can see it. So this is the amount of time that's also required for you to change steps in the production sequence. Now, the key benefits for using this system, we think, is that it's very easy, so there's no real programming language knowledge required. You don't have to type, it's just drag and dropping, so it's really not really programming in that sense. And it also has a very short changeover time benefit for you as a customer, that you don't need to have an engineer from your manufacturer or somebody that has the programming language experience. No, you can just choose the process engineer or the application engineer who has in-depth knowledge of your process and define whatever is necessary for this product. And changing it is really easy, thus providing a short changeover time. And because the system is completely integrated, it has one generic user interface where you can interact with all the elements within the machine. And as I mentioned, you don't need to look for a needle in a haystack where you have a software programmer and a processor application engineer in one. That's necessary within your company. Now, flexibility is another benefit that needs to be mentioned. You can add and or change modules on the setup completely, so on the hardware, and that's also in the case for the software in that sense. And you can reuse the parameter sets that you have made before, or the complete sequences, enabling you to make it real easy to have for another product a similar setup and just change around just as few parameters that are necessary for the system to assemble that product. Now, we believe that the companies that benefit from such a solution is the businesses that already design and or manufacture these photonic components in or systems. Those are photonics OEMs, can be startups, but especially the startups that are already evolving into scale-ups. Of course, also research institutes or universities, and the foundries or contract manufacturers that are already assembling products and producing, but have a customer base that requires them to have a medium to high mix products with a low to medium volume. Now, if you think it's cool and contributing to your process or to your product, please contact us, and we believe we can together achieve many great things and overcome the challenges that we've provided, that we've seen in the market, and give you the solution that is necessary to overcome these. Thank you very much for your attention, and I hope I can contact you soon. Bye.